All right, here we go. Unit 5, Lesson 11.
So here's the math.
Man versus Machine, if you want to watch it. It's a cool video, I think. There was a blizzard last weekend. 5 to 8 feet fell. I got 20 minutes. I got to hustle. Okay. Unit 5, Quiz 4 is going to be after college week. Something fresh. We're doing the Unit 5 art project. We're going to create our own giant playing cards. Should be pretty fun. Field trip approved. Woo! So we're going to do this problem live at the building, the Transamerica building. There's 25 geometry students that are going. It's the 25 top hand raisers, so the 25 top points for Unit 5 get to go. We got to do permission slips. It's going to be awesome. We're going to take Bart over here in Barcadero. We're going to walk to Transamerica, do this problem plus a couple others. I am developing math problems based on Giant Stadium, so can't wait to finish this. And then we'll do some Transamerica ones too. But yeah, I am so psyched about this field trip. So we get to go to Giant Stadium in the afternoon, which is going to be amazing. My goal is I really want to slide into home plate. So part of the reason I'm wearing the Giants hat, even though I'm really a Padres fan, Giants are my number 2 team. But anyway, they said yes. And so did the school. So we're going to Giant Stadium. It's going to be awesome. We got a private tour. 25 people, and just so happens my neighbor is gonna lead the trip. So yeah, here we go. Norms, super important. Equity of voice, it's always a goal. Throwback Thursday, no use for a name. Unit 5, solid geometry. We're getting pretty good at this. We got a cube, sphere, square pyramid, cylinder, cone, triangular, prism. We're getting pretty good at noticing where they are. The cool down, draw 2 solids that are not identical but have the same volume. You'll see that on the video. The other video, the one for Unit 5 Quiz 4, which is coming up after college week. No use for names, the band, Justified Black Eye, 2 minutes 39 seconds. Love this band. Unfortunately, the lead singer, guitarist, passed away, age 41, my age right now. So yeah, sad stuff, but awesome band. And you get to listen to a song by them today. Okay, so ask an old dude or classmate. I encourage you to be the one to answer the questions, because you get 3 points. If you ask a question, you get 1 point. All right, new heights. Calculate the height of each solid. Round your answers to the nearest tenth if needed. I gotta go kind of fast, so for those of you who like the faster pace, you'll probably dig this one. But calculate the height of each solid. So here's A right here. You've got a 17.3 right here on the left, and you've got a right angle here. So what we need to do is write 17.3 right here. Now, you've got a right triangle, the dashed lines plus the hypotenuse. So we're just gonna say Pythagorean for this one. So you want to apply Pythagorean, which, as you know, is a squared plus b squared equals c squared. So we'll just say this is a, this is b, this is c. A and b are interchangeable. This could have been b, and this could have been a. You know that. All right, so we're gonna go 6.5 squared plus b squared. B is the height, by the way, equals 17.3 squared. So 6.5 squared, I believe it's 42.25. So 42.25 plus b squared equals 299. I think it's 29. Let me just triple check. I'm just going off of memory from yesterday. I really don't know what 17.3 squared is. Yeah, 299.29. Okay. Then you subtract this 42.25 minus 42.25. Why do we do that? Because those cancel out. So you're left with b squared equaling 257.04. Once you get there, you got to square root both sides. And you'll be left with b equaling second x squared 257.04 16.03. So 16.03. They said round your answers to the nearest tenth if needed. Let's just say it's needed. So b is 16. So there you go. There's the height of that one. All right, let's look at b. B is a little tricky. Also, it's 16 inches. My bad. Gotta label it. Okay, so we got millimeters over here. So 12 millimeters. You're gonna assume this is 12 right here. Okay. So that's 12, but I want to write it on the left because I know that I'm gonna need this area on the right over here. Okay, so what you do on this is you create a right triangle right here. So right triangle, it's basically a right triangle. Okay. So you've got a right angle right here. This is the height right here. Not the 12. The 12 is not the height. This is the height. And we have to figure it out. So I'm going to color in this 50-degree angle right here. So color that one in. And then I'm going to start labeling things. So H is opposite. 12 is hypotenuse. The next step is you write so, ka, toa. Now we're going to use the hypotenuse, the H, to solve for the opposite, the O. And you have to figure out which one has the O and the H. Well, that is so. So therefore, we're going to rewrite sin of 50 equals opposite. And I want you to always write this because it makes it easier to go just like step by step. Don't skip steps. So sin sine of 50 equals opposite divided by hypotenuse. You already know that, so I can go a little faster, and that's okay. All right, so sin 50 is 0.766. Remember, you always want to use 3 decimals. Opposite is h. Hypotenuse is 12. You got a floating decimal, so we're going to throw a 1 under it. You know what to do next. Cross multiply. H times 1, that's easy. That's just h. And then 0.766 times 12 is 9.193. Well, it's 9.192. I just kept this answer on my calculator. Let's take a look. We changed it a tiny bit. But anyway, they asked you nearest tenth. So 9.193 will go to height equals 9.2. And that's your final answer. You do have to show your work. And nice job. Okay, let's skip ahead. Good pace, good pace. This next one, oh yeah, this part right here. This is really important because this is going to form the Unit 5 art project, which is coming up. So you have to basically draw representations of each of these concepts, and I think I'm going to grade it as much as a quiz is worth. So we're going to call it the Unit 5 art project. And it'll be graded like a quiz. But these are all the principles that we've talked about in Unit 5. So I gave everybody 3 minutes to capture this, and then you have to draw representations of all these. Okay, ways of being smart at math. These are also ways of being smart at life. making quick decisions, being able to ask people questions when you don't know the answer, making connections between things, that's super important. Drawing helps so much. Not only helps you in geometry, but it helps you just to like have fun. That's another big one. Drawing's super fun. Look at this. Like, for me, this is fun. And also it relieves a lot of tension. So if you're ever like really tense, try drawing. Explaining ideas clearly, you're gonna have to meet a ton of people in your life. And sometimes it's not about how you want to communicate, it's how the other person wants to communicate. So you got to learn to read people and talk to them how they want to be spoken to. Extending ideas. Do you just go to school and that's it? Or do you get out of school and think about what you learned and apply it to your real life? So extend your ideas that you learned. Okay. 11.2. Here are several solids. So without doing any calculating, identify 2. That would be the least difficult, and 2, that would be the most difficult. These 2 look difficult. These 2 look easy. But let's do them all. So I've got 15 minutes. I think I got enough time. So let's start with A. So A, this is a triangular prism, which means that the volume equals base times height. So your volume is base times height on prisms. Now, we have a triangle for a base. So you could envision this base right here as the triangle. It says it's 11 by 5. Which means, and you also have a little right angle right here, that the area of this base or triangle is going to be 1/2 11 times 5. Or in other words, 1/2 the base times the height. So 1/2 of 55 will equal 27.5. So our base is 27.5. Our height is 8. Super easy. Just go 8 times 27.5. 220, you gotta get the right units. They're in centimeters, so centimeters cubed. So that one is 220 centimeters cubed. Okay, let's erase and move on. You can always pause the video and go back. But you know that. I don't need to tell you stuff you already know. All right, B. Let's go to B. This one's tricky. You've got a radius of 5. So R equals 5. This is not the height right here, but it is 10. So what do? Well, you draw a right triangle, just like we did before. You draw this right triangle. You label your sides. So 10 is the hypo. So 10 equals the hypo. And then height is opposite. So you go sin 40 equals height over 10. So height will equal 10 sin 40. Clear this out. 10 sin 40. 6.427. So 6.4 is your height. So your height is 6.4. Now you go back to the volume of a cylinder, which is pi r squared height. So volume equals pi 5 squared times 6.4. So 6.4 times 25, 160.69. So I'm going to say 161 pi. They don't give you a unit, so you say cubic units. So your answer for that is 161 pi cubic units. All right, next one. Next one's a piece of cake. This is one of the ones I described as easy. So, not a lot of brain power, which means not a lot of learning, but you should know this by now. Length times width times height. So 7 times 5 is 35, times 10 is 350. So your volume is 350 cubic feet. Pretty easy. I'll just leave it up. Let's go to D. So D, you got another right angle, and you have the hypotenuse. So you got to figure out the area of the triangle, which is going to be 1/2 7 times whatever this is right here. So we got to figure that out, and we're going to use Pythagorean. So 8 squared. So you're going to get 49 plus whatever that is equals 64. Minus 49 minus 49. So question mark squared is going to equal 15. Square root both. Question mark will equal the square root of 15. So this equals the square root of 15. All right. So we still got to get the area. So that is square root of 15. So 1/2 square root of 15 times 7. Whew, got 5 minutes. This is tough. Second, x squared 15 times, wait, hang on.
Good morning, Pumas. Any students attending the John Muir Woods hike, please make your way into the cafeteria. Buenos días, estudiantes. Alguien que esté asistiendo al paseo de John Muir, por favor, vayan a la cafetería en este momento. Good morning, students. Anyone attending the John Muir Woods hike today, please make your way to the cafeteria. Thank you.
Okay, so through all that work, I figured out that the area, if you compute all these, is 13.6. So area is the same thing as base. Got to multiply it by 11. So you're going to go 13.6 times 11. Which is 149.1. And we are in meters, so volume will equal 149.1. This is the final answer right here. In that race, so I'll lose the train of thought. Okay, let's go to E. E is so easy. So radius is right here, 20. Height is 15, so you just go pi 20 squared times the height. So pi 400 times 15, which equals pi times 6,000, or 6,000 pi inches cubed. That's going to be the volume. All right. There's that one. Let's go to F. So F right here. Ooh, tough one. 30-degree angle. 4 right here. You need to figure out this so that you can get the area of a triangle. So let's just call this H for the height of the triangle. So you're going to say sin 30 equals opposite H. Nope, sorry. Mistakes, okay. You're gonna say tan 30 equals opposite H over adjacent 4. So H will equal 4 tan 30. So let's do that. Clear it out. 4 tan 30 is 2.3. So height equals 2.3. Now you got to get the area of the triangle, which is 1/2 4 times 2.3. So your area of that triangle is 4.6. So this triangle is 4.6. To get the volume, you got to multiply it by the height. So times 6.5. you're gonna get 30.02 cubic centimeters for the volume. 30.02. And last but not least, this last one, G, is kind of a beast because we don't really talk about circumference in illustrative math until a little bit later. But you do have it from before. So 4m equals circumference of a circle. So 4 meters. So 4 equals 2 pi r. So let's divide by 2, divide by 2. So that's out of here. So you're going to get r times pi equals 2. And then you're going to have to divide by pi again. So r equals 2 divided by pi. So 2 divided by pi is 0.637. So r equals 0.64. Let's just call it 0.64. So the radius now is 0.64. You know the height is 2. So you just go volume equals pi r squared times height, which equals pi times 0.64 squared times 2. So you're going to end up getting 0.81 pi, or 2.5 cubic meters. All right, that was all of them. What a blitz that was. Okay, I got 5 minutes. Here we go. Halftime, always fun. I highly encourage you other teachers to give your students a 10-minute brain break. It helps so much for the flow of class. Like, sure, you're taking 10 minutes away from class time, but I think kids need it. It's a lot, especially geometry. All right, here we go. The Cayenne Tower. So each floor is the same chevron shape that is approximately 2 parallelograms put together. The circle in the floor plan shows the cross-section of the core, which is used to circulate air and carry pipes and wiring throughout the building. The area of the Cayenne Tower's base is 57 by 35, or 1995 square meters. Why is it possible to find the area of the chevron shape by just multiplying its width and, I should say, length, I believe? So, I'll tell you why. Because there is an area, like right here, that is the same as here. That's why. So it's technically like a rectangle. So that's why we can just go 35 times 57. That's the answer there. Because these little triangles have the same area. Okay. Describe how the total volume of the building can be calculated. So remember, you got 35 times 57, which equals 1995 square meters. That's the area. All right. So what we're going to do is just multiply it by the height, because it's just the same as like a rectangular prism. So the tower is 306 meters tall. So we're just going to multiply this times the height, which is the same thing as length, width, height. So that's volume. So 1995 times 306 equals 1995 times 306 equals 610470. And we are in meters, so you say meters cubed. That equals the volume. All right. What shape is the core of the building? The core, you've got a circle. Cross section is shown in the floor plan, so it goes all the way up this building. It's in Dubai. If we lived in India, we'd probably go to it. But anyway, the shape of the core of the building is a cylinder. Okay, number 4, describe how the volume of the building's core can be calculated, including describing the measurements that would be used. Well, they give you a diameter right here of 17, which means that the radius is 17 divided by
Good
2.
morning, Pumas. At this time, if there's anyone attending the John Muir Woods field trip hike, please make your way to the cafeteria.
So, volume,
Estudiantes, en este momento, si van a
5
asistir
r
al paseo de John
squared,
Muir, por favor vayan a la cafetería en este momento.
8.5 squared.
Students, at this moment,
Times
please go to the
306.
cafeteria if you are attending the John Muir field trip. Thank you.
So that'll equal 22,108.5 cubic meter. Alright, volume is 22,108.5 cubic meters. What percentage of the building's volume is taken up by its core? So you just gotta go core volume over the whole building volume. So it's 22,108.5 divided by this. 610,470, which equals, hang on, 22,108.5 divided by 610,470. It's so weird, hang on. I don't think that's right. Give me a sec. One more time, clear this out. 22,108 divided by 610,470. Yeah, 3.6%. So I'm getting 3.6%. All right, that's it. Nice job.